Hello viewers, welcome back to Reflux in the series of Gate 2024 EC solutions. After completing the last playlist on solutions from control systems subject, this time I have come up with the solutions from signal systems, questions that came in Gate 2024 EC, detailed solutions. So basically 6 questions came from signal systems, 2 of 1 mark and 4 of 2 marks. So let's start with the very first question of 1 mark, MCQ type. Question number 21 in the official master question paper of Gate 2024 EC from subject signal systems is as follows. 1 mark. It is given a causal and stable LTI system with impulse response h of t produces an output y of t for an input x of t. Now, a signal x of 0.5t is applied to another causal and stable LTI system with impulse response h of 0.5t. Right. The resulting output is the options given are A 2y of 0.5t, B 4y of 0.5t, C 0.25 y of 2t, and D 0.25 y of 2t, y of 0.5. Let's move on to solution for this question. Okay, easy question. It's quite simple, straightforward. Using the properties of continuous time convolution, causal and stable LTI system with impulse response h of t gives the output y of t. That is, y of t is the convolution of x of t and h of t. Right? The signal is x of 0.5t is applied to another causal and stable LTI system with impulse response 0.5t. H of 0.5t. So we have to find if this convolution basically. Right. If yt is the convolution xt and ht, then what is the convolution of x of 0.5t and h of 0.5t? Okay. Let's go by the definition. Mathematical definition of convolution. Right. It's x of tau y of t minus tau t tau, right, minus infinity limits. Now let's put 0.5 tau as in the other variable, say y. So this becomes what? X is minus infinity to infinity. If you put minus infinity here, y will be minus infinity. If you put plus infinity, y will be plus infinity. The limits will remain unchanged. Same, right? Okay. It will be x of y 0.5 tau, y of 0.5 tau minus y basically h of sorry, right? T minus. If we expand this x of t, h of t conversion, then how do we write this as minus infinity to infinity x of tau h of t minus tau b tau. Here there is t, here there is t. Now here there is 0.5 t, right? Okay, and d tau will be replaced by what? 0.5. We differentiate both sides. 0.5 d tau equal to dy. So d tau equal to 2 dy. So now we replace d tau with dy. 2 comes before, so it will be dy minus infinity to infinity. Now y is here a dummy variable because it is inside the integration. So we can replace y with tau easily. So we can write this as minus infinity to infinity x of tau h of 0.5 t minus tau d tau. Now if we put t here, there is t, so this is a function of t. If we replace t with 0.5 t here, so y will also be a function of 0.5 t here. So this is same as this. Only t is replaced by 0.5 t. So y of t will be replaced by y of 0.5 t. So this will be simply 2 times y of 0.5 t. So therefore the answer is simply as 2y of 0.5 t. If the signal x of 0.5 t is applied to the causal and stable LTI system, the inverse response h of 0.5 t. That is, the output will be 2 of y of 0.5 t, which exactly matches option A. So the right answer for this question, a little bit tricky but simple only based on the property of continuous time convolution, is option A. I explained and solved and explained the process by using the property or the standard mathematical definition of continuous time convolution, shown the proper steps and explained also in detail. Hope this is clear. If you have any doubts or queries, please feel to ask in the comment section. And that's all for the solution to this question. Moving on to the next question. This is a daily easy solution subject signal systems. Next question is again a 1 mark, but this time MS2 type multiple select question. Can have more than one multiple correct answers. Question number 24 in the master official question board gate 2024 AC from subject signals and systems from basically set transform causal discrete LTI system is as follows. Question number 24, 1 mark, MSED. It is given for a causal discrete time LTI system with transfer function h of z 2z square plus 3 upon z plus 1 by 3 z minus 1 by 3. Which of the following statements is not true? Which of the following statements is or are true? Option A, system is stable. Option B, the system is a minimum phase system. Option C, the initial value of the impulse response, value of impulse response is 2. Option D, in the statement D, the final value of impulse response is 0. Let's take the options one by one. Move on to a solution for this question. Simple question actually. This is based on discrete ETA system, discrete time ETA system. The transfer function is given as 2z square plus 3 upon z plus 1 by 3 z minus 1 by 3. Basically, we need to locate the poles and zeros and comment on the stability and other things based on that. Pole location is what? Z equal to plus minus 1 by 3. Zero location is what? 2z square plus 3 equal to 0. In other words, z equal to z square equal to square root of minus 3 by 2 equal to z equal to square root of minus 3 by 2 what? Root 3 by 2 plus minus j. So if we draw the pole zero diagram, as root 3 by 2 is greater than 1, so the zeros will lie outside the unit circle. It is here. Zeros will lie somewhere like this. Minus root 3 by 2, j root 3 by 2, j root 3 by 2. And the poles are lying over inside the unit circle here. Minus 1 by 3 and 1 by 3. This origin, this is the unit circle, that is mod z equal to 1. This is u axis, this is j axis. Now we can clearly see that the poles are lying inside the unit circle, or the zeros are lying outside the unit circle. System is stable as the poles are lying inside the unit circle. Right? Poles are lying at plus minus z equal to plus minus 1 by 3, which is inside the unit circle. That is, the ROC includes the unit circle, the ROC includes the unit circle centered at origin, then the system is stable. Obviously. Minimum phase system, this is not a minimum phase system. For resisting to minimum phase, all the poles and zeros should lie inside the unit circle. But here again we can see that zeros are lying outside the unit circle. So is non-minimum phase system or not a minimum phase system? Non-minimum phase because the poles are lying inside the unit circle, but zeros are lying outside the unit circle. Right? Initial value is basically what? Initial value is h of 0 is what? Limit z tends to infinity, z hz. If you put infinity here, limit z tends to infinity, 2z square y plus 3y, z plus 1 by 3, z minus 1 by 3. Infinity means these terms will be cancelled, the constant terms will be neglected. 2z square by z square will be what? 2. So right, the initial value of the impulse response will be 2, correct. Now let's look at the final value. Final value will be h of infinity. Defined as limit z tends to 1, z minus 1, h of z. Right. As there is no z minus 1 term in this denominator, so z minus 1 term will not get cancelled. If you put z equal to 0, z equal to 1, so z minus 1, 1 minus 1 will be 0. So this will basically come down as 0. Come out to be 0. The final value of the impulse response, as you can see, is 0. System is non-minimum phase and it is stable. As it is stable, we are able to apply this initial and final value. So otherwise, we won't be able to apply. So the correct answers for this question are A, C, and D. And the solution is very simple. First, try to locate the poles and zeros, draw the pole zero diagram. Based on that, comment on stability. And if the system is found stable, as it is true here, you can find the initial and final value. And minimum phase, you can say that it is non-minimum phase because the poles are lying inside, but the zeros are lying outside the unit circle centered at origin in the z plane. So, I hope the solution is clear. I have explained the solution in detail. If you still have any doubts or queries, please feel free to ask in the comment section. And that's all for the solution to this single question. Thank you. Moving on to the next question. In this series of GATE 2024 EC solutions from subject signal systems. Next question is of 2 marks, MCQ type from time shifting and scaling. Inversion, time shifting, scaling operations. Effect of inversion, time inversion, scaling, shifting on Fourier transform. Question number 44 in the master question paper Get only to signal systems as follows. 44 nuance MCQ is given. Consider two continuous time signals x of t and y of t as shown below. Here is given images. So this is given wrongly, 0.5 should minus 0.5, and the question is given 0.5. That is why it has become MTA, otherwise the question is correct. Question is otherwise correct. So it is given like this, x of t and y of t. X of f denotes Fourier transform of xt. Fourier transform of yt is yf is yt yf in terms of xf represent. Options are given as minus 4x of 4f e to the power minus j by f. Option B, minus 4x of 4f e to the power minus j 4 by f. Option C, minus 1 by 4 x of f by 4 e to the power minus j by f. Option D, minus 1 by 4 x of f by 4 e to the power minus j 4 by f. These are the options given basically. Let's move on the solution of this question. Very simple actually. You have to represent first y of t in terms of y of t in terms of x of t. Y of t can be written as x of t minus 2 by 4. Right? First expand x of t. It will become something like this. Now shift right 2 units to the right. So it will become something like this. Now invert it. It will be minus. Basically. This is x of t by 4. This is x of t minus 4 by t minus 2 by 4. And this, we invert this, it will be minus of x of t minus 2 by 4. That is y of t. Now if we substitute, we take t minus 2 by 4 as, and then we will say u. So what? T will be 4u plus 2 and dt will be what? 4 du. Now let's use this in the standard mathematical definition of Fourier transform, which is y of f equal to minus infinity to infinity y of t to the power minus j to y of t dt. And x of f is what? It is basically minus infinity to infinity x of t to the power minus j to y of t dt. Let's put here in place of t, let's put x of this, so x of u to the power minus j 2 pi f 4u plus 2 du 4 du and this is dt. So if you take 4 outside, it's minus infinity to infinity x of u to the power minus j 8 pi f, sorry 4 pi f into e to the power minus 2 pi u into 4f. So if you take 4 e to the power minus j 4 pi f outside, so you get minus infinity to infinity x of u e to the power minus j 2 pi u into 4f. This is basically what? Let's write it here. Here see. This is basically what? Minus of this, minus c. Here this is minus c. Minus. So this is basically what? Minus x of 4f times e to the power minus j 4 pi f. This basically matches with option B. As you can see, the correct answer for this question is option B, but it is given empty because here instead of minus 0.5 it is written 0.5, which is wrong. So I will explain the solution for this question in detail. If you still have doubts or queries, please fill those in the comments. And I will also explain why it is empty. So that's all for solution to this simple question. Thank you. Moving on to the next question in the series of get into AC solutions from subject signal systems. Next question is also of 2 marks, MCQ type from sampling basically and impulse response concepts of continuous time signal. Question number 48 in the master question, official question paper get from the EC from signal systems is as follows. 2 marks, MCQ type is given a continuous time signal x of t 2 cos 8 by t plus pi by 3 is sampled at a rate of 15. Sampled at a rate of 15 Hz. Right? The sampled signal XST when passed through an LTI system with impulse response h of t sin 2 pi t by pi t times cos of 38 pi t minus pi by 2, right, produces an output x0 t. The expression for x0 t is asked. Expression a bit conceptual and also somewhat lengthy, I would say. As many steps have to be followed. Option A 15 sin 38 pi t plus pi by 3. B sin 15 sin 38 pi t minus pi by 3. C 15 cos 38 pi t minus pi by 6. And D 15 cos 38 pi t plus pi by 6. So basically this is the question. Control system signal is sampled at a certain rate, frequency given, and the impulse response of the system is given. We need to find the output basically. So it is convolution in time domain or multiplication in frequency domain. Let's move to solution. Let's find the Fourier transform of both the signals, so that you can multiply them directly. दोनों को multiply करने से आउटपुट का Fourier transform मिल जाएगा. Fourier transform भी निकाल सकते हैं, नहीं तो हम लोग जो ये साइनसॉइड स्टेडी स्टेट में xt साइनसॉइड स्टेडी स्टेट में ना, तो इसका जो फ्रीक्वेंसी है उस पर हम लोग इम्पल्स रिस्पॉन्स का जो मैग्नीट्यूड और फेज है वो मैग्नीट्यूड को मल्टीप्लाई करने से फेज को ऐड करने से आ जाएगा. तो xt का क्या है फ्रीक्वेंसी 8 पाई बाई 2 पाई 4 और फेज है आई 5 पाई बाई 3. लेकिन बट इधर ट्विस्ट सैंपल नहीं किया गया. सैंपलिंग करने से क्या होता है, जो फ्रीक्वेंसी का जो 2 cos 8 pi t plus pi by 3 होता है 4 f मॉड मैग्नीट्यूड ड्रॉ करेंगे xf का, तो हो जाएगा 4 पे हो जाएगा 2 by 2, मतलब तो इसका है, इसका हाफ हो जाता है 1, ऐसे हो जाता है -4 पे ये 1 ऐसे हो जाता है. लेकिन क्योंकि सैम्पलिंग किया गया, नाउ देयर विल बी इनफाइनाइट सैंपल्स ऑफ दिस एंड द स्केलिंग फैक्टर इन दिस केस विल बी 15 और fs. So after sampling, the response becomes something like this: 4 space as interval से 15 Hz, and the magnitude will multiply by 15. So it will be 15 times 15 now. Like this. Okay. Now this will be next one will be 15 minus 4, that is 11, 19, like that. Here it will be minus 4, minus 11, minus 19, like that. The magnitude part after sampling, it is excess f mod. ठीक है. फेज में भी वही होगा, सेम थिंग विल हैपन फेज, and this frequency the phase will be pi by 3, and at the reverse the minus negative of this frequency it will be the opposite, because phase is symmetrical in an odd function of frequency. So we will consider this later. I'm just drawing this for reference. Now let's take the LTI system impulse response. Impulse response को भी हम लोग एनालाइज करेंगे, नॉट इन टाइम बट इन फ्रीक्वेंसी डोमेन HF. मतलब क्या करना पड़ेगा, इसके लिए फूरियर ट्रांसफॉर्म लेना पड़ेगा HF का. फूरियर ट्रांसफॉर्म में दो ऐसा फंक्शंस दिया हुआ इसमें जिसका फूरियर ट्रांसफॉर्म को पहले से पता है. पहले से HF क्या दिया हुआ है, sin of 2 pi t by t times cos of 38 pi t minus pi by t. sin of 2 pi t हम लोग 2 से मल्टीप्लाई करते हैं और डिवाइड करते हैं, तो ये क्या हो जाएगा 2 times sin of 2t. sin t क्या होता है, sin pi t by pi t. sin of 2t क्या हो जाएगा, sin 2t 2 pi t by 2 pi t. तो 2 by 2 कैंसिल हो जाएगा, तो ये बचेगा जो दिया हुआ है वो बचेगा. This will be 2 sin 2 by t into sin of something minus pi by 2. Pi by 2 is 90 degree. Cos of, sorry. Cos function is what? Even function. So this is same as cos of pi by 2 minus this. Cos of pi by 2 minus some angle we know is sin of that angle. So it will be sin of 38 pi t. Now this is a bit complicated function because it is the product. Now if we convert it into the frequency domain, right? You have to take the convolution of the individual, that is the Fourier transforms. Fourier transform of 2 sin 2t is, you go to the duality property, then you will get t rect of t by t gives t sin of ft. Similarly, rect of f by, similarly if we take the Laplace transform of t sin tt, then we get rect of f by t. So it will be, if we put t equal to 2 here, so we will get this 2 sin 2t. So now we can directly replace t by 2. So we will get what? This that is transform this as 2 rect of f by 2. And this that is transform, we have special case which is 2 pi times delta of 38 pi by 2 pi, that is 19. So f minus 19 minus delta of f plus 19 by j2. Okay. So this will be minus j pi, or let's say j pi times delta of f plus 19 minus delta of f minus 19. And this will be what? This will be simply, let's draw at this frequency 19 and plus 19 minus 19, there will be an impulse of pi units scale. And this one will be what? 2 times, so it will not put here, vector f by 2. So vector f by 2 is what? It will be 1 when f by 2 is less than half and greater than minus half. So f is between 1 minus 1 and 1. So this is this one. And its magnitude will be 1. So basically, if we take the convolution, the multiplication in time domain means convolution in frequency domain. So convolution by any impulse signal means shifting the other signal by that. I mean, convolution with this will give basically this thing. So will be pi. This also will be pi. And now center frequencies will not be minus 1 and 1. It was minus 19 and 19. Now center frequency will be converted to 19 and minus 19. So this will be minus 19 minus plus 1 minus 18, minus 19 minus 1 minus 20. This will be 18. This will be 20. Something like this. And the phases will get added accordingly. I am not showing that. I will show you later, of course. Okay. Now if we take this frequency, I mean, there will be several frequencies in this sampled version of XS. Now the frequency that will come in this range will be only 19, because the remaining frequencies will get rejected, because they will not lie in this band. So only the frequency which is 19, the component which is frequency of 19, that is an angular frequency of 19 to 2 pi, that is 38 pi, will pass through. So that h of 19 will be what? H of 19, let's put as 19 here. So it will be basically minus j pi. We put 19 here. This term vanishes. This will be minus times. This will be 1. This will be minus j pi. So magnitude is what? H of 19 magnitude is what? Pi. And angle is what? As you can see, angle is what? Minus 90 or minus pi. So basically, to the sinusoidal, the sampled version of xt, if we pass it through this filter having these characteristics at frequency of 19 Hz, then the output will be magnitude gets multiplied. Magnitude is what? Pi. Pi will get multiplied to 15. Right? Here the magnitude is 15 for the component at f equal to 19. So 15 into pi. So that is 15 pi. And the angle of the phase will get added. Phase at 19 is what? We have not found out actually. Phase at 19 will be basically what? Same as phase at 4, because these are the repeated samples. Right? At intervals of 15. Like that. So phase at 4 is what? Phase at 4. Basically it will be, I think, pi by 3 only, right? So to pi by 3 minus pi by 2 will get added. So it will be 15 cos will remain cos. Since sinusoidal steady state, magnitude is getting multiplied. This magnitude gets multiplied with magnitude of the filter at response at f equal to 90. 15 by cos of this frequency, same as the frequency equal to 19 for the sampled version, and the frequency will be here, of course, 19 into 2 pi, that is 38 pi, and the phase addition due to the filter will be what? The phase at f equal to 4, that is pi by 3, same as phase at f equal to 19 for this sampled version, and to that we will have to add minus pi by 2. So plus pi by 3 minus pi by 2, basically it will be what? 60 degree minus 90 degree, that is minus 30 degree. Minus 30 degree means what? Basically minus pi by 6. So basically what we get, the output will be 15 pi cos of 38 pi t minus pi by 6. Now we know cos of sine of pi by 2 plus theta will be cos theta. So you can add pi by 2 to this and write sine also. So you can write 15 pi sine of 30 pi by t plus pi by minus pi by 6 plus pi by 2, that is 90 minus 30, that is 60, pi by 3. So this is 30 pi t plus pi by 3. So the correct alternative for the output x0 should be 15 pi cos of 30 pi t minus pi by 6 or 15 pi t sine of 30 pi t plus pi by 3. But in the options we see that pi term is missing. Otherwise, we should match with option A and option C. But while setting the question, they have wrongly omitted or maybe forgotten to put pi as one of the factors in the magnitude, and that makes the question actually wrong. Otherwise, the options A and C will be correct, but as they have not put pi term factor in the numerator, then it goes wrong. So this actually question has gone for MTA, marks to 1, marks given to all candidates because of this mistake done while setting the question. And the answer should be this one, 15 cos as I explained, 15 pi cos of 30 pi t minus pi by 6 or 15 pi sine of 30 pi t plus pi by 3. And the steps are detailed. First, let's summarize. First, taking xt, doing its frequency response analysis for its original version and then its sampled version. In sampled version, if you magnitude plus multiplied by a factor 50 with the sampling frequency, and there will be infinite samples, such samples. Next, we take the impulse response for doing frequency analysis in the frequency domain. First, we take both the terms in the time domain, convert into there, take the Fourier transform, then do as their product in time domain, so it will be convolution in frequency domain. So do the convolution using the property of delta function. We get something like frequency response of HF, something like this. Magnitude and phase also we will consider. Now what we do? We basically do what? We will put among all the infinite frequency present, only the frequency at if you go to 90 will pass as you can see from the magnitude and response of the LTI system. So the magnitude of the filter if you go to 19 is considered, and the corresponding magnitude is multiplied with the magnitude of the sampled signal, and the phase is added to get the expression of the output as this. As the factor pi is missing, this makes the question the option is incorrect, though the question is correct. I hope I have clearly explained the steps of this little bit tricky question, I would say, complicated question and lengthy also. I have tried to explain it simply using the basics of sampling and frequency domain analysis, convolution and all, time shifting, frequency shifting and all those things, those properties. Hope the solution is clear and it really helps. Still, if you have doubts or queries related to this, please feel free to ask my comments. And that's all for solution to this question. A little bit tricky and complicated. Thank you. Moving on to the next question in this series of get into easy solutions from subject signals and systems. Next question is also of 2 marks, MS2 type this time, multiple select question. I think may have more than one correct answers, multiple correct answers related to basically period of a discrete time sinusoidal signal. Question number 56. So called controversial question. Question of 56 in the master official question paper get 20 EC in subject signal systems as follows. Once MSP what is that question is given the radiant frequency of the radiant frequency values so for which the discrete time sinusoidal signal discrete time sinusoidal signal x of n a cos omega n plus pi by 3 has a period of 40 is or are. Options are given as quite simple actually, but unnecessarily aspirants or candidates have a tendency of complicating it. But in fact it's quite simple. 0.3 pi 4 pi. Question is given as sinusoidal discrete time signal is given in this form a cos omega n plus pi by 3 as xn is asked for a period of 40 which of the radiant frequency values are possible. The values of omega are asked. Let's know the solution of this question. Possible values of omega. Values of omega for having period n equal to 40. As per definition of period, we know if a function has a function signal has a period of capital N, then x of capital N plus capital N, small n plus capital N equal to x of n. As per standard definition. Now basically you have to check this. For what values of omega will have will this definition satisfy? This is mind. This here the fundamental period is not asked. I will also solve this question using the definition of fundamental period later at the end. So let's put options one by one. Let's say xn equal to a cos 0.5 option A, pi plus pi by 3, n plus 1, 0.5 pi n plus pi by 3. Now if we put x of n plus 40, we get what? A cos 0.5 pi n plus 0.5 into 40, pi into 40. That means what? 6 pi plus pi by 3. Now cos of 2 pi or any multiples of 2 pi plus some angle will be same as this, same angle, right? It will be same as a cos of 0.5 pi n, 0.15 pi n plus pi by 3. This is simply same as x of n. So basically we can say that 0.15 pi is the period of 40 is the period of xn if omega to 0.15 pi. So 0.15 pi is correct. Let's move to the next option. A cos 0.225 pi n replacing omega by 0.225 pi. Now let's simplify. X of n plus 40, let's find. X of n plus 40 means a cos 0.225 pi n plus 0.225 into what? Pi into 40. 0.225 means 9 by 40. So 9 by 40 into 40 is 9 pi plus pi by 3. So it will basically what? A cos odd multiples of pi plus some angle will be minus cos of that angle. Cos of odd multiple of pi plus some angle will be minus of cos of that angle. So minus a cos 0.225 pi n plus pi by 3. So this will be minus of xn, basically xn is this one. So it will be minus of xn is this one. this is not equal to xn. But by the definition of period, it should be equal to xn. xn plus n is to technically 40. So this is not a period of xn. I mean, 40 is not a period of xn if omega equal to this value. Let's check for the other options. Xn equal to say a cos of 0.3 pi plus pi by 3. Let's do it a bit fast. N plus 40 gives a cos of 0.3 pi n plus 0.3 pi into 40 means what? 12 pi. Again, even multiple of pi plus some angle, cosine of that will be that angle, that cosine of that angle only. So we will cosine of 0.3 pi n plus pi by 3. Basically, it will be xn. So it is satisfying the definition of period. So 0.3 pi is also a period of 0.3 pi is also a possible frequency, radian frequency value for which the period of xn is 40. Let's take the last option, which is option D. It will be what? A cos 0.45 pi plus pi by 3. X of n plus 40 will be again a cos 0.45 pi n plus 0.45 pi into 40 means 18 pi plus pi by 3. 18 pi is again a even multiple of pi. So adding anything with that angle 2 pi n plus n pi plus theta is a cos theta. So it will be a cos of basically 0.45 pi n plus pi by 3. This is basically equal to x of n. So again it is satisfying the definition of period of function xn. So it is 0.45 is also a period of xn. Possible radian frequency value for which the period is 40. Now this is the standard approach. So the correct answers for this question are A, C and D. There is another approach, finding the fundamental frequency. Fundamental frequency for fundamental, if this is 40 is taken the fundamental frequency, let me see, then what should be the value of omega? Right, this is the question. And from the definition of fundamental frequency, this should be like into omega. Yeah, so the another approach I discussed earlier, that I will be discussing later, regard using fundamental frequency is the finding the fundamental frequency and any frequency in multiple fundamental frequency will give the same period. Fundamental frequency is given here in this case by 40, the period into fundamental frequency will be equal to 2 pi, should be equal to 2 pi. So fundamental frequency is made as 2 pi by 40, that is 0.05 pi. Any frequency in multiple fundamental frequency will have the same period. You can check. Here we are getting options, correct options is 0.15, 0.3, 0.45 pi, all which are multiples of 0.05 pi. So I explained both the approaches and also the detailed steps. Hope the solution is clear and comprehensible for this pretty straightforward question. If you have any doubts or queries, please feel free to ask in the comments and I will be glad to answer. And that's all for solution to this single question. Thank you. Moving on to the next question and the last one in the series of AC solutions from the subject signal systems. Question number 59 from the topic Fourier transform, discrete time Fourier transform, is as follows. Question number 59, 2 marks. You have to answer given. Question number 59 is given the relationship between any n length sequence. The relationship between any n length sequence x of n and its corresponding n point discrete Fourier transform. Corresponding n point discrete Fourier transform. X of k, capital X of k, is defined as we all know x of k equal to Fourier transform x of n, right? Now is given another sequence y of n is formed as y of n equal to Fourier transform of x of n. Okay. Of the sequence x of n equal to 1, 2, 1, 3. The value of y of 0 is, question basically demands the value of capital Y of 0 when y of n is this sequence. We transform 4 times of x of n. Let's move to solution for this question. Solution आसान ही है. We will use the cyclic property of discrete time Fourier transform and discrete Fourier transform DFT. Okay, cyclic property is very easy actually. We have to manipulate the inverse function in the multiple times occurring Fourier transform in such a way that it comes in the form of inverse. Let's say like this. I'm saying, as we all know, Fourier transform of xn is x of k, capital X of k. Okay, so nothing but summation n equal to 0 to n minus 1 for discrete sequence of length n, x of n. So given as n equal to 0 to n, x of n e to the power minus j 2 pi k n by n. This is definition. ये definition mathematical definition इस ये होता है. अब इसका हम लोग अगर इनवर्स पेयर लेते हैं, उसको वो क्या हो जाता है, x of n 1 by n summation k equal to 0 to n minus 1 capital X of k e to the power minus नहीं होता इधर j 2 pi k n by n, right? ऐसा होता है. now इन दोनों के यूज करेंगे अगर 2 times Fourier transform हो उस केस में. there are if Fourier transform occurs 2 times, you use these two and this pair, inverse pairs. Okay, now what we can write, summation say let this be y, suppose this be y of n, or say as y of n is given, let's see it's some other sequence, let's say z of n. Okay, तो हम उसका कंसीडर करते हैं z of n, ठीक है. और z of n का जैसे ये z of n है, suppose ये z, ये आप ठीक है ऐसे लिख सकते हैं. एक f ऐसे लिखते हैं, ठीक है। इसको लिख सकते हैं फूरियर ट्रांसफॉर्म x of n to f taking non-linear x of k, so it is fूरियर ट्रांसफॉर्म x of k basically, राइट। फूरियर ट्रांसफॉर्म x of k क्या हो जाएगा, समेशन k equal to 0 to n minus 1। ऐसे इसमें हम लोग x of n की जगह कैपिटल X of k रख दिए, कैपिटल X of k to the power minus j 2 pi k n by n। नाउ ठीक है, हम लोग दोनों साइड को k को हम लोग माइनस के से रिप्लेस कर देते हैं, ठीक है। k को हमने इसको सपोज z ऑफ n ले लेते हैं, ठीक है। हम लोग बोथ साइड्स को n को माइनस से रिप्लेस करते हैं, n से कैपिटल n से डिवाइड कर देते हैं, और टेकिंग माइनस replacing n by minus n on both sides and divided by the whole meaning capital N, so z of minus n by n you get 1 by n summation k equal to 0 to n minus 1 x of k to the power n replace n by minus n, so this minus gets vanishes, you get j 2 pi k n by n। can I draw the similarity, ये किसके साथ बराबर हो रहा है, ये हम लोग ने ये निकाला था ना, ये भी वन टर्म्स इक्वल है कि नहीं है, बिल्कुल इक्वल है, सेम है। इसको हम क्या लिख सकते हैं, बेसिकली x of n, ठीक है, राइट। तो z of n को हम लोग क्या लिख सकते हैं, आप फिर से हम लोग रिप्लेस कर दें n को माइनस n से, z of n को n हो जाएगा z of n by n, और इधर x of n था, x of minus n हो जाएगा। now taking n to that side we get z of n equal to x n x of minus n। So here there are two times Fourier transform. So n comes once and minus 1 to the power 1। So अगर n दो बार Fourier transform अगर होता है तो n का पावर इधर 1 होता है, माइनस 1 भी एक बार आता है, तो एक माइनस रह जाता है। और इसको हम लोग अगर ये करते हैं, जनरलाइज करते हैं, तो f of डॉट 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 अगर n टाइम्स होता है से k टाइम्स होता है, ठीक है। तो ये जाते हैं n to the power k by 2, यहाँ k जैसे 2 है, तो 2 को 2 by 2 1, तो n to the power 1, x of minus 1 to the power k by 2, यहाँ पे k कितना है 2 है, तो 2 by 2 तो minus 1 to the power 1, मतलब minus 1, तो माइनस रह जाएगा and n, ये जनरलाइज हो जाता है सेकंड प्रॉपर्टी। मैं डेराइव किया, मुझे ऐसा कुछ याद नहीं था, I had to derive it and then use this, generalize this। तो अब इसमें कितना दिया हुआ है क्वेश्चन में, y of n निकालते हैं मेरे से, y of n कितना है, सिमिलरली f of कितना टाइम्स 4 टाइम्स है, तो फिर क्या है बेसिकली k equal to 4, मतलब n to the power 4 by 2 x to the power x of minus 1 to the power 4 by 2 n मतलब क्या हो गया n square x of n minus 1 to the power 2 होता है, minus 1 square मतलब 1, तो n square x n। तो हम लोग इससे हम लोग लिख सकते हैं कि y of n equal to n square x of n। यहाँ n मतलब लेंथ ऑफ द सीक्वेंस, लेंथ ऑफ द सीक्वेंस here given is 0 1 2 3, so 4, so it will be n square मतलब 4 square times x of n, that is 16 x of n। Now finally what we need to do, finally we need to calculate y of capital Y of 0, which is nothing but the Fourier transform of y of n for at k equal to 0। Putting k equal to 0 in this expression, let's say this is y and this is capital Y, we put k equal to 0, then all the exponential terms vanish, exponential 0 हो जाता है। बेसिकली हम लोग क्या होता है, x0 plus x1 plus x2 plus x2 डॉट xn माइनस 1, यहाँ पे n 4 है तो x0 plus x1 plus x2 plus x3, तो यहाँ पे ये जब x था तब ऐसा था, अब x को अपन y से प्लस कर देंगे तो क्या हो जाएगा, ये y हो जाएगा सिंपल, ये वाला तो वैनिश हो गया क्योंकि k0 है इधर, ये हो जाएगा y0 plus y1 plus y2 plus y3, और y क्या है, y of n क्या है 16 x of n, x of n क्या है ये सब, तो बेसिकली ये हो जाएगा कितना, जगह कम मैं यहाँ पे करता हूँ, y of 0 आपका हो जाएगा बेसिकली 16 टाइम्स, क्योंकि 16 कॉमन है, x0 plus x1 plus x2 plus x3 मतलब 16 टाइम्स 1 plus 2 plus 1 plus 3, right, 1 plus 2 is 3, 3 plus 1 is 4, 4 plus 3 is 7, 7 into 16 is 112. So y of 0 we get easy guess 112. This is a numerical answer to question, हम लोग को इसमें numerical value fill करना है, तो y of 0 का करेक्ट वैल्यू जो हम लोग को साइक्लिक प्रोबेबिलिटी ऑफ फुल ट्रांसफॉर्म है उसे मिल रहा है वो है 112. I have shown the detailed steps how to obtain the answer. Let's summarize. Applying cyclic property, first deriving x of k in terms of x of n, taking the inverse, using both these equations to derive and generalize the relation between the nth time cyclic Fourier transform and the actual original discrete sequence, which you get as x z of n equal to n times x to the minus n, or taking Fourier transform k times we get n to the power k by 2 x of minus 1 to the power k by 2 times n, where x of n is the original sequence, this is the Fourier transform taken k times in cyclic way. So in the here k is given as 4, so 4 times Fourier transform is taken, so we get y of n as n square x of n from these relations. So just we put n equal to 4, the length of sequence is 4, 4 terms are there, so we get y of n equals 16 x of n. Now y of capital Y of 0 is the Fourier transform of y of n calculated at k equal to 0, 0 frequency. So there we put here generalized expression for discrete Fourier transform, we put k equal to 0, we get y of 0 is the sum of y of 0, y of 1, y of 2 and y of 3, which is nothing but n square times x0 plus x1 plus x2 plus x3, x1 means 16 times x0 plus x1 plus x2 plus x3, which is nothing but 16 into 1 plus 2 plus 1 plus 3, which we get as 112. So I have described the process, the detailed steps, and also explained the logic or the reason behind calculating or proceeding in this way. I hope the solution is clear. A bit tricky question actually, but I have tried to explain it. I have tried to simplify it and explain it using detailed steps and explanation. Hope the solution is clear. If you still have any doubts or queries, please feel free to ask some comments. That's all for solution to this question from signal systems, and also that's all for the subject signal systems. Thank you.